Hi, so in this video we'll be learning about the equation of the plane in intercept form. By intercept form, I mean the place where a particular plane is cutting our x-axis, y-axis and z-axis. I've already defined a plane over here, that is minus 4x minus 6y minus 3z is equal to minus 12. So if you see, that is cutting our x-axis at x is equal to 3, cutting our y-axis at y is equal to 2, and cutting our z-axis at z is equal to 4. So if you see, the coordinate of this point where it is cutting is 3, 0, 0. Here it is 0, 2, 0, and here it is 0, 0, 4. So the x coordinate and y coordinate is 0 at this point, only we have the value of z. So it is where our plane is cutting through the axis and going indefinitely to the other side, right? So the idea is to express the equation in terms of these intercepts, writing them in terms of this 4, 2 and 3, where 3 is the x-intercept, 2 is the y-intercept and 4 is the z-intercept. Yeah. So let us try to derive the equation in terms of intercept form. We know that the general equation for a plane is ax plus by plus cz plus d is equal to 0, where at least one of them is not equal to 0. So let us say the points where the plane cuts the x-axis, y-axis and z-axis is as follows. It is a, 0, 0, 0, b, 0, and 0, 0, c. So if these 3 points lie on the plane, that means they should satisfy this equation, right? So now what we are going to do is we are going to substitute this particular coordinates in this equation, this in this in this, and we are going to obtain 3 such equations. So substituting this value in the general equation, we get a plus d is equal to 0. Substituting this value, we get bb plus d is equal to 0. Substituting this value, we get cc plus d is equal to 0. Now expressing them in terms of the capital A, capital B and capital C, where this capital A, capital B, capital C are there in the original equation. So our idea is to just substitute these values back in the original equation. So we get A is equal to minus D upon A, and B is equal to minus D upon B. C is equal to minus D upon C. We know that the original equation is AX plus BY plus CZ plus D is equal to 0, right? So we do have the values of A, B and C. So substituting it here, we will be getting minus D upon A, X, minus D upon B, Y, minus D upon C, Z, plus D is equal to 0. Now we'll be taking D common and cancelling the D's, we will be getting the following. So we have this, taking D over that other side, we have X upon A plus Y upon B plus Z upon C, having minus D common taken out, is equal to minus D. So this minus D and minus D gets cancelled. So we have X upon A plus Y upon B plus Z upon C is equal to 1. So this is the intercept form where A is the x-intercept, B is the y-intercept and C is the z-intercept. So if we look at this equation also, dividing it throughout by minus 12, we will be having 1 on the right hand side. So here we will be having x upon 3 plus y upon 2 plus z upon 4. That are actually the intercepts of x, y and z axis respectively. So we can actually try to generalize that particular example for any general equation. So if we are given with any equation, we can rewrite this as ax plus by plus cz is equal to minus d. So this is minus d. Yeah. So dividing it throughout by minus d, we have a upon minus d x plus b upon minus d y plus c upon minus d z is equal to 1. So our right hand side is being tallied. So we just have to express this as x upon something plus y upon something plus z upon something, right? So we can express this as x the whole upon minus d by a plus y the whole upon minus d by b plus z the whole upon minus d by c, which is equal to 1. So in this way, given any general equation, we can actually convert them or reduce them into intercept form.